In this video, I'm going to show you how to translate a shape, and there's two ways to do it, so make sure you stick around and watch both ways. I'm going to also talk about some properties of translations as well as some examples. So get your pencil, get your paper, and let's go. What's good, YouTube? It's Alma with the Sauce, and I'm back with another tutorial. If this is your first time here, you need some math help, start right now by subscribing to my channel and hitting that bell so you can be notified every time I drop a video. What is a translation? So a translation is one of the four basic types of transformations, and it's probably the easiest one because all you're doing is basically sliding the shape. And so how that works is you take a pre-image, which is the image before you make the transformation, and you translate this, or you slide this shape along what we call a translation vector. Basically what a vector is it tells you how many spaces to move in the horizontal direction and how many spaces to move in the vertical direction. And you might see it one of two ways, but either way, the A is going to represent how many spaces you move left or right. You're going to move to the right if it's positive and to the left if it's negative. And then B is going to let you know how many spaces to move in the Y direction. So if B is positive, you're going to be moving up. If B is negative, then you're going to be moving down. All right, so now that we know what a translation vector is, we can talk about the two ways to translate a shape. And so the first way to do it is to just look at the vector and then just add those distances to the coordinates of the pre-image. All right, so let's say I wanted to take triangle ABC and translate it along the vector 5, -3. That just means that basically this triangle is going to move 5 spaces to the right and 3 spaces down. And so the easiest way to do it is to just move 1 point at a time. And so if I look at my first point, which is A, I see that that's at -5, 7. And basically what I'm going to do is just add 5 to the X coordinate and subtract 3 from the Y coordinate. And then that'll give me my points of A prime, which is called the image. You know, the pre-image is before we move the shape, and then the image is after we move the shape. So A prime is going to be whatever my pre-image was, which is -5, and then I'm going to add 5 to it. And I'm going to do the same thing with my Y coordinate. Whatever my original Y coordinate was, I'm going to subtract 3 from it. And I'm just going to do that with all 3 points, and then I'll end up with the 3 points of my image, and then I can just plot that. So now that I got all of my image points, I can just plot those points, and then that'll show me how to get the resulting image of the whole triangle. And so as you look at the pre-image and the image, there's a couple properties that I want to talk about. So the first thing is, you know that this is a pre-image because there's no apostrophes or primes on them. This one is going to be called the image because there's primes after each of the letters. So that's how you know the difference between the pre-image and the image. And the second thing I want you to see is that because we did the same thing to all 3 of these points, everything about our image is going to be the same as our pre-image. So the distance from A to B is going to be the same as the distance from A prime to B prime. All these angles are going to be the same. Everything is the same. And so when that happens, we say those two shapes are what we call congruent. And the other thing I want you to notice is, what if we were to connect all the pre-image points to their corresponding image points? Something happens. So once you connect the pre-image points to their corresponding image points, you can see that all 3 of those connections are parallel. So that's how we know everything got moved in the same direction. And then the other thing that's true is that all 3 of these segments are congruent, or they have the same length. And so that lets you know we went the same distance and the same direction to make the translation. And so the other way we can do this translation, instead of doing it this way, is to just count. And so I can look at my vector and say, if I know I need to go 5 spaces to the right and 3 spaces down, 1, 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. And so I can just do it manually like that and just do it point by point. So both of those are going to get you the same result. And so that's basically how you perform a translation. One of the reasons translations are so easy is because all you're doing is taking some points and adding or subtracting from those points. And that's really all you're doing. It says we got triangle ABC being translated along the vector -3, 8. So what that means is it's going to be moving 3 spaces to the left and then 8 spaces up. So if A, B, and C are given, what are the coordinates of triangle A prime, B prime, C prime? So basically all we're doing is taking these original pre-image points, subtracting 3 from the X coordinate, and then adding 8 to the Y coordinate. That'll give us the coordinates that we want. So before just diving right into it, one of the things that makes it a lot easier is to just come up with a general rule for getting the coordinates of A prime, B prime, and C prime. So looking at this vector, we know that all of our X coordinates are gonna go to the left 3 and up 8. So our rule can be, we take some point X comma Y, and then you already know that we're gonna subtract 3 from the X coordinate and add 8 to the Y coordinate. And so if we know this rule, we can easily find A prime, B prime, and C prime. Our coordinates of A prime are gonna be the original X minus 3. So 0 minus 3, which is gonna give me -3. And then for the Y coordinate, I'm gonna add 8. So it's gonna be -4 plus 8. So basically that's all you got to do. Get you a rule and then just add or subtract whatever numbers come from the vector, add or subtract those from the X coordinate and the Y coordinate. All right, so for this last example, it says point A, and it gives us the coordinates of point A, was translated to form A prime, and it gives us the points or the coordinates for A prime. What translation vector mapped A to A prime? So this one's a little bit different because we know where we started and we know where we finished, but now we just got to basically figure out how we got there. So just like last time, I know that point A has coordinates -5, 12, and I know it somehow got to A prime, which was 3, 8. And so basically, again, I'm going to use a rule. So -5 plus some X gave me 3, and then 12 plus some Y gave me 8. So I just got to figure out what is that X and that Y. And so there's 2 components to it. There's the component for the X direction, and then there's a component for the Y direction of our vector. And so looking at the X's, we started off at -5, and I add some X to get me to 3. And I just got to figure out what that is. For the vertical component, I started out at 12, and then I ended up on 8. So 12 plus some Y is going to get me 8. So now I just got to do a one-step equation to figure out my X and my Y, and then that'll be it. So my final vector is going to be 8, -4. I took point A and I moved it 8 spaces to the right and then 4 spaces down, and then it got to A prime. And so that's all you got to do. All right, so thank y'all for watching the video. Hopefully it helped. If it did, don't forget to hit that thumbs up button. Don't forget to subscribe if you're new. And with that being said, I'll see y'all in the next video.